Hi all, I'm myself ANJUSHA R, Assistant Professor, Department of Civil Engineering, Vedavyasa Institute of Technology. I would like to express my gratitude to Vedavyasa Institute of Technology to give me such an opportunity to to do this tech talk. So, a simple topic. I'm here going to discuss a simple topic on framed structures. So, what is a framed structure? So, in this discussion, I would like to include a small introduction, definition, then what is the behavior of earthquakes, that the effect of earthquake on framed structure, advantages and disadvantages, and framed structures with different materials like concrete, wood, steel, etc., and a small conclusion. So, as an intro, a framed structure in any material is one that is made stable by a skeleton that is able to stand by itself as a rigid structure without depending on floors or walls to resist deformation. Materials such as wood, steel, and reinforced concrete are examples of this, which are strong in both tension and compression. So, framed structure, can we think about a human body without a skeletal system? So, that is the whole skeletal system is making the body in shape and in rigid or in stable condition. Similarly, any framed structure with any material should be stable by its skeleton to stand by itself as a rigid structure. So in case of a framed structure, we can say it can be it should not be depend for stable to be by itself as a rigid structure should not be depending on floors and walls to resist the deformation. So, have you ever thought of a skeleton of a building as the main factor design, or do you usually resolve at the end of the creative process? Now, coming to a definition, a frame system is one whose principal structure elements, consisting of beams and columns connected through rigid nodes, forming resistant frames in two main directions of analysis, which enables the transfer of bending moments and axial loads to the column. So, in general, when we discuss about a frame system, it is a principle, or it is one whose principal structural elements consisting of beams and columns which connected through rigid nodes, which may forming a resisting frames in two main directions, mainly say Z and Y directions of analysis, which enables the transfer of bending moments and axial loads to the column. So here the transferring of the load is converted to moments, bending moments and axial loads to the column. So whatever the load coming under the beam will transfer as bending moment and axial load to the column. Now what is behavior? The relative stiffness of beams and columns will be the main consideration that giving when earthquakes are considered. The design of connections, the relative stiffness of beams and columns, and the areas which are exposed to earthquake, the limit be around 20 floors, and high seismic risk zone, that limit must found in about 10 floors. So in earthquake prone areas or in earthquake considerations, first we consider the relative stiffness of the beam and columns, then the connections, beam column joints, then how it is connected. If we consider steel, what type of connection to be given for the in between beam and column, etc., are considered. And in case were areas exposed to earthquake, the floors are limited to 20, and in a high seismic risk zones, the story is limited to 10 floors. Now, for satisfactory seismic response, we have to take some things in account. So some of the necessary things that we take into account are weight of the structure, plan form, height way, axis alignment, separation, redundancy, and strong column, weak beam consideration. So first of all, the weight of the building is the most important thing what we have to consider in seismic response. Then plan form, height way of the structure, then the axis, that is if axis of symmetry or if unsymmetrical, what is major axis or which is minor axis, that is to be considered. Separation, that is when buildings are nearby, that is within meters, the next building is considered. So the separation between these buildings has to be considered. Redundancy, regarding the support conditions, what all are the redundancy, that is number of degree of freedoms and all is considered. Then strong column, weak beam consideration, and that theory also has to be considered. Now, some of the advantages and disadvantages. Greater freedom, some of the advantages: greater freedom in the distribution of the inner space of the building. They are very flexible structures that attract small seismic action. By the use of brick walls in the frame system, the heat transmitted to the inside of the building is less than the other structures. Now, coming to disadvantages, this type of wet construction is slow, heavy, and therefore more expensive. Its flexibility allows large displacements, which causes damage to non-structural elements. Use of this structural system is limited to low and medium structures because as the building has more floors, have to be greater the size of the column, which can make the project economically and architecturally unviable. Now, we can say there are a number of materials that are used in the field of construction. So, some of the main materials that are considered in framed structures, that is in construction of framed structures, the main thing is concrete. The structures are the result of a combination or mixture of materials with different characteristics such as concrete and reinforcement steel. In this case, the steel is placed on the bottom because it is in the tension zone. Later is emptied the concrete. So this is a figure showing a concrete framed structure with beams and columns, and the slabs are provided over it. Next is wood. So wall framing in a house construction includes the vertical and horizontal members of exterior walls and interior partitions, both of bearing walls and non-bearing walls. More maintenance is required in this case of framing structures. Next, corners. The multiple stud post made up of at least 3 studs or the equivalent is generally used at exterior corners and intersections to secure a good tie between adjoining walls to provide nailing support for the interior finish and exterior sheathing. You can see a figure. Our older before the inventions of concrete and all, the old houses, old buildings were like this, based on wood corners. This is ballong framing. You can see here with wooden studs and ties. This is platform framing, which is started from 1930 to present. So here you can see foundation, header joist, floor plate, joist, stud, etc., etc. Double top plate, cap plate, subfloor, stringer joist, bridging, gable stud, collar tie, rafter, ridge beam, etc. So this is a normal or platforms framing that is done from 1930, and some of the it is continuing present also. Now the recently or the more widely opting frame structure nowadays are steel structures. So it is based on the same principle of wood, but is much simplified by the far greater strength of the material, which provides more rigidity with fewer members. The column and beam are fused by riveting or welding. Stresses are distributed between them, and both can be longer and lighter than in structures in which they work independently as post and lintel. So you can see some of the figures of steel framing structures. So I sections, channel sections, like that. A lot of I sections are available in the market. So based on that, based on the type of buildings and purpose of building, we can choose different sections, which is already precast or already precast unit available as precast unit in our market. So just get it from the market and just we have to connect it with proper connections. So easier way of connections, easier way of forming a framing building. So most of the structures nowadays are constructing with steel building. Conclusion: the structural configuration can be considered the fundamental aspect in the entire structural design. These conclusions are deduced from the experience gained in past seismic events, showing that well-structured and detailed buildings have satisfactory performance even without undergoing profound analysis and calculations. Buildings with frame system has proven to be one of the most resistant to earthquakes and also one of the most flexible spatially. So that is about the framing structures. Thank you all for listening my small tech talk.